welcome back. Good morning to all. So, we will continue our distributions. So, in the last class we have introduced the distribution, the convolution of a distribution and a function with one of them has compact support, either the T has compact support or phi has compact support, and we also seen that you can recover your distribution if you know all the convolution products, and that is a very thing. So, it is essentially if you know convolution product, not essentially, if you know convolution product you know the distribution theory, okay. And if you know distribution you have all the convolutions at the, you can get back all the convolutions products. So, it is a basically one way if and only if things like that. So, today I am going to describe some important properties, and if I get time I will see whether I can prove it at the end of the second lecture. So, because I want to finish something. So, we have your properties. Okay, let me do this one. Okay. 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 I hope properties. Okay. So let T be a distribution. T is in distribution. You can also equivalently take and phi is in Rn, phi is in Rn, or you can also take T is a distribution with a compact support E prime. In that case, oh sorry, this is in D of Rn, okay, or it can be an E prime of Rn. In that case you can have phi is in C infinity of R, any of them. Then you have this standard formulas. One, this is the translation of T star of phi. T star of phi is a function, understand that. The convolution of a distribution and function is a function. So, you can take the translation. I will tell you what is the translation with respect to x, translation of x t, and then you know the translation of phi function. Then I will also give you the definition of translation of a distribution. Phi that is also is equal to, you can take the translation wherever you want, Tx of phi 2. You can also have your d power alpha of T star of phi is equal to d power alpha of T, because d power alpha of T is defined all the time. So, you see phi that is equal to T star of d power alpha of phi for all multi-index alpha, and 3, and in particular here, in particular okay, T star of phi is C infinity, okay, 3, and if further, if psi is in D of Rn, then you have your you have your associativity, T star of phi star of psi is equal to T star of phi star of psi, that is any point, and for immediate. And if this we already mentioned d prime with T star of phi equal to 0 for all phi in D, then that implies T identically 0. T identically 0 means T phi equal to 0 for all phi. Okay. So, what is your translation of your function? So, how do you get motivated the translation of thing, you just apply when it is a function tau x of f is equal to f of x minus y, tau x of f at y is equal to f of x minus y, and see the distribution generated by that and see what formula it gives you. So, the definition of which motivates, so that the translation of t, which is a distribution given phi is equal to t acting at, there is a minus sign will come, tau minus x of phi, and we also have this formula which you can check, tau x of phi chess yesterday, the inversion is equal to tau minus x of phi at chess. Okay. You can verify this, you verify. Okay. This also you can verify when verify, that is how it got motivated, verify when t equal to tf. Okay. From that, this is the kind. So, you have to use these things to prove it. The proofs are algebraic, but it is a very subtle proofs. So, let us see whether I will get time to go to that. I do not see its this is the problem, I do not see its arrow. Let us see, let us keep it here. Okay. So, what is next to do it with that one? Now, with that, so this proof if possible I will give it later. Now, we will do convolution of two distributions. Okay. So, of course, one of them T s d prime. So, the minimum condition we assume is that one of them with compact support, one of them with the compact support. So, we will again motivation via functions. So, you need to get a formula, you are using the same philosophy which you are going to do that. In the previous case, maybe I forgot to tell some proposition if you want, not about this one, the previous one. So, support of, because T star of phi is a function. So, if T has compact support and phi has compact support, this will be in support of T plus support of phi. If you want, you can verify that. Okay. So, you have this is true, okay, for the earlier case. So, one of the that one. Okay. So, let us give the motivation again, how to define. There are various ways of defining the convolution product T star S. So, I will mention couple of things, and third one is using tensor product and all that. So, if you I will not present that way of defining using tensor product, either you can define it in a kind of an axiomatic way or by getting this motivation. So, you can do that one. So, let us consider Fng, consider Fng, okay, consider Fng, two functions and f star g, that is how you think, and look at this is how you look at it. So, T produced by f star g. So, whether it will give some formula. So, when that formula can be used to define the convolution of that T star only, if Tf and Tg, and then how does it represent. So, let phi is in D of Rn, D of Rn. Okay. So, let us look at T f star g at phi, that is equal to, how do you define? It is integral over Rn of f star g of x, x minus y, whatever, f star g of x. So, what is, so maybe I will write in two steps, you are still not confused. This is equal to f star g of x into phi of x dx. So, this you will write it as integral f of y g of x minus y phi of x dx. So, you have dy here. So, as usual Fibini, this is what you keep on using it, f of y, you will have some term integral of g of x minus y phi of x dx of dy. I call this to be psi. If I call that to be psi of y, and so you will get this, in that case you will have integral of f of y psi of y dy. In that case this you can write it as Tf acting at psi, whatever be psi, whether psi have compact support etc. I am not bothered now. It is a kind of writing as a distribution in terms of psi. So, we have to compute what is psi. This is by now convolution product. This is nothing but Tf star psi chess at 0. This we have seen. Tf at psi is nothing but Tf star, because the convolution product and action of the distribution can be connected all the time here. So, Tf star g of phi is Tf star psi chess at 0. So, you have to understand what is psi chess. So, maybe I will put it in this page itself, so that you do not have to go to the next page. So, what is psi? Psi is this one. So, I have to understand what is psi chess. So, psi chess of y. So, maybe some steps you probably understand, that is equal to psi of y minus y, and if I substitute that there, so that will be integral of g of x plus y psi phi of x dx, phi of x dx, substitute that t, x plus y equal to t. So, this is equal to g of t and phi of t minus y dt. So, you get that one, and this you can compute. So, this is Tg acting at this translation, this is phi of t y minus y. So, it is acting at the translation. So, this is nothing but Tg acting at tau y of phi, and that is same as Tg star features at y by definition. So, you can combine, the moment you have these things you can combine here. So, psi chess of y is nothing but Tg of features of y. So, use this here, if you use that here, so you will get this is equal to Tf star psi chess is Tg star psi phi chess, okay, that is your psi chess. So, evaluated at 0. You see. So, what does this imply? So, that is your Tg f star g when the distribution is given by acting at phi. This is a possible definition if everything is meaningful. Tg star features at 0. Okay. So, that gives you a definition if with the everything is meaningful. So, that gives you the definition. T, let T s belongs to a distributions R n with one of them having compact support, one of them having compact support, then define T star S as T star of S acting at phi as a distribution. So, you are defining T star S from D to R n, D to R. Okay. T star of S is equal to T star S star features at 0. So, let us look at the well definedness, right. So, you have to always see the well definedness of that. If S has compact support, then you already know by the previous proposition S star feature is in D of R n. That implies T star of S phi star of S. You see, it is a convolution with a D function is well defined. You do not need the compact support of well defined. You do not need the compact support of T because S star of features has a. On the other hand, if T has compact support, okay, clearly S star of features S only if S has compact support, S star of features will be in D, but then this will have is in, that means that is here T is in E prime, that is the meaning of that one, that is D is in E prime. S star of E is in E, need not be in D. Again T star of, because then you can define the operation if T has compact support, the acting function need not have compact support, is well defined. Okay. So, in both cases one of them T star of S star of feature. So, you remember this formula. Okay. So, you have that one. Okay. So, yeah, there is some more space here. So, this a remark or another way of defining convolution. So, the issue is that one can also define using the characterization, one can also define axiomatically, in the sense the following, define in some sense axiomatically, not really axiomatically, so I do not write it. Define T star of S. Yeah, by the way, the here you can check the continuity easily. Okay. It is not difficult to, sorry again, it is not difficult to check the, if you are not confused, check the continuity of phi, continuity of T star of S. So, this I will leave it as a trivial thing, because if you have to prove that if I n converges to 0 in D, show that T star of S of E n converges. Use the continuity of T and S. Okay. That implies T star of S is a distribution D prime. Okay. All right. So, can also define, so let us come back, can also define T star of S using the characterization via using the characterization via via the what do you say, convolution. Via the I will tell you what exactly it means. So, what does that mean? So, is T and S are two distribution. If T star of S has to be defined, if that has to be defined as a distribution, whatever way it is, we do not know how to do it, distribution. So, what I am saying is that if T star T and S are distribution, you want to define T S star S has to be defined as a distribution. Then it must satisfy, then it must be given by, must be T star of S, whatever it is, whether you exist or not, because it should do this one, it has to be this should satisfy T star of S star of features, right. What is the formula? I just want to do that one. T star of S, no sorry, so let me, so T star of S. So, you know that, recall the way any distribution has to be defined as this one, features. That is what you have already seen it, evaluate at 0. Okay. That is how you recall that, okay, because recall T acting at phi is nothing but T star of features acting at 0. So, if there is any definition to be defined, so T star of S must satisfy this. So, if I call this is to be star, so this is to be double star, okay, then precisely T star S is the unique distribution satisfying the associative law. So, basically the RHS of star and double star should match, and then it is given. So, the star gives you the formula, second one you are demanding the associative law, okay. And you will see that there are distributions. If I get time, I will give you an example. There are distributions for which you can define T star of S star as something else may not be equal to that, associative law may not be satisfied for arbitrary distributions. So, the other basically the second definition is T star S T S in D with one of them having compact support, having compact support, then T star S is the, I am not going to do anything, unique distribution satisfying the associative law, satisfying T star of S star of features is equal to T star of S star of features, okay. So, associative law is satisfied and is given by the formula, and T star of S, then you define at phi, this is star, okay, T star of So, you are basically defining features at 0, because these are the two formulas you need it for definitely. If T star S is defined, it has to be this form and then the associative law. So, you match these two. So, the distribution is given by that one. So, an immediate can prove immediate, which I do not prove in most of the things here. Proposition, if T S is in E prime, that means both of them have compact support, and then T star of S is also in E prime, and support of T star of S is contained in support of T plus support of S. Okay. So, you have that, and similar formula is also there. Definitely I do not prove it here, that is much more easy. As I said, the earlier one I might prove it. So, you have other proposition. This I will only state here. I hope I will have place here, because proposition, let T I belongs to D prime I equal to 1, 2, 3 with 3. Okay, then 1 So, wherever it is valid, whatever formula I think, sometimes you need one of them has compact support, sometimes you need 2 of them have compact support. T1 star is T1 star, T2 equal to T2 star T1. Of course, you here need one of them as compact support. Okay. So, wherever the formulas are valid, you assume, and support and this one support we already written, support of T and S is already written. So, we can put it that theorem if necessary here. So, okay. And 2 T1 star. So, you have your formula, in fact we are defining like that, right. T2 star so, you have the associative law, T3 is equal to T1 star T2 star T3. In this case you need 2 of them, have compact support, then only these products are defined, well defined support. And third thing, the important thing again, you have d power alpha of T1 star T2 is equal to or T power alpha of T1 star T2 is equal to, you can put the derivative anywhere you like it, T2 that equal to T1 star. All requires some small proofs, 1 step, 2 step proof. So, it is if you are studying first time, it is better to prove it, go through that, it will familiarize not only distributions, also these convolutions very well. Okay. And maybe some few one more thing I will and then I will go do it in the next class. So, one example to start with, of course. So, you will see now in the class of distributions how Dirac delta. So, it is a typically an identity under convolution product, that implies T star of delta is equal to delta star of T, that is equal to T. So, you see under the in the class of distributions under convolution products delta works like a unity, okay, identity and that product. More generally, you can compute now that one, right? D power alpha of t is equal to d power alpha of delta. You can put it where you like it, star t, and okay, so can you get this one? You see now. Of course, you can write it delta star d power alpha of t if you want that. So you see. So for every d power alpha of t, delta works like an identity if you want it. You don't need a proof, but it's almost trivial. So let's see if you want a quick proof of that. It's an exercise. So t star of delta, one part, let me at least write it. Phi is equal to, by definition, t star of delta star of features evaluated at 0, okay, and that's equal to t star of delta star of features is features. So this is features. Did I mention that? Delta star of phi, that delta star of phi is phi. So if you want to put, if you have not done that one, that's a small exercise. Delta is a distribution with a compact support, so this is equal to phi. That you can verify. That's quite easy, right? So look at the definitions. Delta acting at features, you get it, and the features, all that you can write down immediately. Okay, you just use the definition. Just write out the definition of delta star of phi, and then you get phi. So this is phi at 0, that's same as t at phi. That's the way you look at it, right? So t star of features at 0 is equal to t phi. So you will get it. All right. So you get back this one. So you just write down the steps. All the steps. If you are not convinced, you should do that one. Okay. So you get that one. So delta star of features is. Okay, so the other things you can also prove, and maybe with one small example, one more thing, one more remark, and you can also define T1 star, T2 star, etc. for finitely many, T2 star, etc. for Tm star, if at least n minus 1 of them have compact supports. And there is no ambiguity because of the associative law. So you can define whatever order, it does not matter, there is commutativity and associativity. So which way you are bracketing it is the material, that is what you do it for the usual product. So for this, so that is why commutativity and associative will help you to define in a, without an ambiguity you can define the product. Okay. But let me see whether one example can be okay. So already 35 minutes. So I will continue this one and give you the associative. You may be able to define T1 star T2 star T3 and T1 star T2 star T3, but it may not match. Okay. So we will continue and we will tell you few more things about fundamental solution and other things. Thank you very much.